This is setting it up to be the box method because if you have forgotten, the area of a rectangle is equal to the length times the width. So that's what we essentially are doing right here. Okay? Length times the width. All right. So this is the box method, which I think most of you prefer in this class. Some of you might like double distributive. You could also do that. When I do that, I am going to take 5y times 2y, which is at the very top. And I'm going to take 5y times 6. All right? Now, I'm going to multiply both of these to get the answer. 5 times 2 is 10, and y times y is, what is y times y? Y to the second power, or y squared. Okay? Then I have 5y times 6. I need to multiply those coefficients times that constant. So that's 5 times 6, that's 30. And I just have 1y. Then I go to the second row and I multiply -5 times 2y and -5 times +6. So in the bottom left-hand corner of my box method, -5 times 2 is -10y, and -5 times 6 is -30. Okay? Where am I going to find my like terms in the box method? Do you see any like terms? Yeah, it's always going to be on the diagonals, right? We're looking at these numbers in black, okay? So 10y squared, that's the only y squared value I have, plus I have parentheses 30y plus a -10y, and the last one is -30. Well, what is 30y plus -10y? 30 plus -10 is what? 20y. And over here, this 10y squared stays the same out in front. Plus, and then behind the 20y, I have -30. Now, let's see what it says. Write an expression. Is that an expression? 10y squared plus 20y minus 30? Is that an expression or an equation? Do I have an equal sign there? It's an expression. So it is an expression in standard form. What do I have to have for standard form? Greatest to least degree. Here I have a degree of 2. I have a degree of 1 if I wanted to write that down, and a constant has a degree of 0. So have I completed all they're asking for? Yes. So this is your final answer. That is the area. An area is length times width. Okay? Questions on that? All right, let's take a look at number 2. I'm an Android user myself. How many iPhone people are out here? Anybody iPhones? Okay, nice. All right, the new iPhone is rumored to be smaller than the iPhone 16. What is the current iPhone? Does anybody know? I don't know. It doesn't matter. The iPhone 16 Pro has a width of 7 centimeters, okay, and a length of 14. Apple wants to reduce the length and width by the same amount. Find the area of the new iPhone. That's interesting. All right, so I'm going to draw a picture of an iPhone. Actually, I'm drawing a picture of a rectangle, and it says the width is 7 centimeters And my length is usually longer, is 14 centimeters. Apple wants to reduce the length and the width by the same amount. Do they tell us what that amount is? No, but it's the same, right? How could I represent the amount we're going to make it shorter? How can I represent that? Okay, we are going to subtract it, but how much am I subtracting? How much am I subtracting? Naima, do you know? If we don't know, how do we usually represent that? What is my unknown? Isn't that usually a variable? Yeah. So we are going to reduce by X amount. We're going to reduce. And when I reduce, that means I'm going to use what operation? Huh? No. How else do you reduce things if you make them smaller? Subtract, right? So we're going to reduce by X. Okay. So find the area of the new iPhone. Area, again, of a rectangle is length times width. And of course, I'm running out of space. Length times width. Hopefully yours is not messed up like mine is, like this. All right, so this time I'm going to use double distributive method, okay? My length was 14 centimeters. If I reduce it by X, what is my new amount? What's my new amount going to be? It was 14, and I want to reduce it by X. What's my new amount going to be? Guys, come on, put on your thinking caps. No. It was 14. I'm going to reduce it by X, which we said we're going to subtract X. So what is that amount? It is going to be 14 minus X, right? So this is my new length, which is X amount shorter. What is my new width going to be? Lens, what's my new width going to be? It was 7. Now it's going to be does anybody know? Wouldn't it be 7 minus X also? You're taking X away from both, okay? Taking X away from both. So we got to multiply. All right, so I am going to double distribute on this one. If you want to do the box method and set it up with a box, you can. So I am going to do 14 times 7. And I am going to do plus 14 times negative X. Okay. Then I take my second term, negative X. So that is plus a negative X times the first term here, which is 7, plus a negative X times negative X. So everybody see how I did that? That's double distributive. All right, 14 times 7 is going to be 98 plus 14 times negative X is negative 14X plus negative x times 7 is negative 7x. Notice I'm putting those negatives with the parentheses around them just so I know they are negative. Plus, what is a negative times a negative? A positive, and x times x is, that's going to be x squared. Okay? All right. Here are my like terms inside in the middle. Let's put it in standard form. So x squared is going to be first. I've got negative 14x and a negative 7x. So that's an even bigger negative. That is negative 21x. And my last number, which is a constant, plus 98. That is my area. And if I wanted to be over the top, because this is math and we're talking about area, did they say? It's centimeters. So this would be centimeters squared. Centimeters squared. Okay? But do you understand the problem? The original phone was 14 by 7. They want to reduce, that means make smaller, the length and the width by the same amount. So that's why we subtracted x from each one. Does that make sense now? Do you see that? Yes? No? All right. Let's go to number 3, another word problem. Jessel is expanding her garage at her house. Currently, the garage has a length of 22 feet and a width of 17 feet. She wants to add, here we go, twice as many feet onto the length than she does to the width. She wants to add twice as many feet onto the length than she does to the width. Write polynomials to represent the length and the width. All right, we're talking about her garage. The original, I'm going to put the original underneath. So it was 22 feet. And the width was originally 17 feet. She wants to add, so what operation is that going to be? Plus, right? So I'm going to say 22 plus, she wants to add twice as many feet onto the length than she does to the width. Do we know how many feet she's going to add? No, but we know it's going to be twice as much as she does for the width. If I don't know what that amount is, I'm going to let that be my variable, right? So twice, that's going to be 2 times twice as many feet. I'm going to say 2x. It was 22 feet. She's going to add twice as many feet onto the length than she does to the width. So the width of the garage was 17 plus, what is, if the length is twice as many and she doesn't add twice as much, she just adds the regular amount, what am I adding to the width? Am I adding the same amount, 2x? Let's see, she wants to add twice as many feet onto the length than she does to the width. So she's not going to do twice as much there. She's just going to do x. So she's adding twice as much to the length than she does. When you say than, it means she's not doing the same amount. All right, so this is 2x, whereas this is just x. All right, letter B says, find the perimeter of the garage. Well, what shape is this garage to begin with? Is it a circle? A triangle? A square? A rectangle? What is it? Rectangle. So here's the garage. It's going to be rectangular. The length is usually the longer side. So I'm going to say this is 22 plus 2x. The width is going to be 17 plus x. Now, usually we kind of have these switched around, but that's okay. Now, it is saying perimeter. How do you find perimeter of something? What does that mean? If I said you need to walk the perimeter of the gym, what would you walk? Has your gym teacher ever had you do that? What's the perimeter? Do you know? They've told you to walk it and you just walk it? You don't know what it's at, what it is? What is perimeter? Yes, very good. Yes, the perimeter is the distance around the edge. Distance around the edge. Distance all around. Okay? So, if you are finding the distance, am I going to be multiplying here? I mean, I'm going to walk here. Here's my person right here. We're going to walk this way. Then we're going to walk this way. Then we're going to walk this way. Well, what is this length down there? What is this right here? What is this distance? If it's a rectangle, isn't it 22 plus 2x? Yeah? Okay, and then you're going to come back up here. What's this distance over here? 17 plus x. So if the perimeter is the distance around, you need to add all the sides. So we're not multiplying here. We're actually adding. Okay? So I have 22 plus 2x. Then I have 17 plus x. And 22 plus 2x. And I have another 17 plus x. I have my like terms. I have 2x, an x, a 2x, and an x. Those are all like terms. The x's could have a 1 in front. So if I put those all together, 2x plus 1x plus 2x plus 1x, how many x's do I get? No. 2x plus 1x plus 2x plus 1x is 6x, right? 2 plus 1 is 3, plus 2 is 5, plus 1 is 6. Plus, now I need to add all my constant numbers. 22 plus 17 plus 22 plus 17. Get that old calculator out. Anybody grab a calculator? 22 and 22, that gives me 44. And 17 and 17. Ooh, 14, 18, 2, 4, 6, 7, 78. Check my math. Anybody check it? So my perimeter is 6x plus 78. And how do they label it? Feet. Now, we're not talking about area here. We're not talking about square feet of 1 foot by 1 foot. Put that away. Please take out your notes. So this is the perimeter. That is a singular distance, okay? Any questions about that much of it? We're going to finish this problem, if we can, at the top of the next page. All right. Now it says find the area of the garage. Okay. So here was my garage. Have you ever noticed some people call it a garage? Have you ever heard that? A garage? No? All right, so what were the measurements again? The length is 22 plus 2x. I'm going to put that at the top. 22 plus 2x. And my width was 17 plus x. Okay? Take your handy dandy calculators if you've got them. So I am taking 17 times 22. Omar, do you have that for me? 17 times 22? A little louder. 39. Is that what you said? 22 times. We got to multiply. 22 times 17. A little louder. Really loud. Thank you. 374. Now I have 17 times 2x. 17 times 2 is 34x. Then I have a positive x times 22. Okay, that's 22x. And my last one is x times 2x. And that gives me 2. And what's x times x? X times x? X squared. Here are your like terms. So when I combine them, I get 374 plus parentheses 22x plus 34x, because I know those are my like terms. I can combine those, plus 2x squared. And you're like, why is this backward? Well, it just is, but we'll fix that in a minute. So 374 stays the same. 22x plus 34x, you only add the coefficients, the numbers in front. 34 and 22 is 56. X plus 2x squared. Is this in standard form? Is it going from greatest degree to smallest? No. So we gotta flip these two right here and write it as 2x squared plus 56x, which has a degree of 1, plus 374. We're talking about area, so this is feet squared. Whenever you're talking about area, it is your units squared. All right. Is this the last page of our notes? All right. We are going to stop for today. Yay! Do you have any questions on homeworks 1, 2, or 3? So, homework number 3 technically was supposed to be due today. I thought that was a little quick. Homework number 3, we're going to make this due Monday. Okay? Make sure you do the weekly Canvas activity. Oh wait, I didn't say put all your stuff away yet. And homework number 4 is going to be due on Wednesday. Guys, this is pretty much the end of our notes. So that means our test is next Friday. Now, this is only a 50-point test, not a 100-point test like the last one. Okay? Take out your homework number 3. Let's take out your homework number 3.